Okay, class, welcome back. We are starting section 8.4 today. So we are going to be using solutions of quadratics. So before we get started, I'd like you guys to think about this question that you have right in front of you. Can you think of at least 3 methods for solving a quadratic equation? So think back to what we've been doing. Can you think of 3 methods? Well, I have 3 that I'm going to offer to you guys. First one, which you might have not even thought about because it's so obvious to you, is factoring. Done a lot of factoring. That's one method that we can use to solve for x or solve a quadratic. The next one that we learned just recently is completing the square. Like my square there. And the last method that we most recently learned would be the quadratic formula. Okay, so those are 3 methods, and there are more. There are definitely more out there. Those are 3 methods that we have been focusing on for solving a quadratic equation. So, today we are going to work with solutions of quadratic equations. So our objective, we're trying to determine the nature of solutions of quadratic equations. What are they going to be like without even calculating it out? And we're going to find and use sum and products of solutions and to use find a quadratic given its solution. So we're going to derive that. Okay. First, to determine the nature of the solutions of a quadratic, we simply need to evaluate the expression under the radical called so before this, what we would call this underneath the radical, we called that the radicand. Well, in the quadratic formula, we refer this as the discriminant. Okay, so a new name for this. The discriminant is b squared minus 4ac underneath this radical of the quadratic formula. Okay, so what are we talking about? To determine the nature of the solutions of a quadratic? Well, we worked with imaginary numbers and we worked with real numbers before. And it turns out that solutions to quadratic equations can be imaginary, they can be complex, they can be real, and there can be a combination of those. So we're going to look at the nature. What do they look like? What kind of solutions are we going to get from solving a quadratic? So let's look here. We have an equation ax squared plus bx plus c equals 0. It has different solutions based on the value of the discriminant. We just define what a discriminant is, which is b squared minus 4ac. So, if b squared minus 4ac is less than 0, so if we get a negative value underneath that radical sign, then we have 2 complex non-real solutions. So we remember what those look like. We've just been working on those, especially in chapter 7. So they could take the form of a plus bi, and those would be the solutions to it. They aren't real numbers. And that is if we get a negative underneath a negative discriminant. Now, if our discriminant is positive, so it's greater than 0, we will have 2 real number solutions. So we're most familiar with this one. If we get a positive number, we can take the square root of it and get 2 real solutions. Now if that discriminant is equal to 0, then we say we have exactly 1 real number solution. We just have 1. Okay, so we're going to look at a couple problems, and without even solving for x, we're just going to look at the discriminant and try to determine the nature of the solutions. So here we're asked to determine the nature of the solution. Okay. So here we have 8x squared plus 9x plus 1 equals 0. So we're just going to follow these steps. Step 1 says put into standard form. Well, it appears that we were already given this in standard form, so we can keep it the same. Next, we're asked to identify A, B, and C. So our A is 8, our B is 9, and our C is 1. Next, we are asked to evaluate the discriminant. So in doing so, remember our discriminant is B squared minus 4 times A times C. So we have all values of A, B, and C. Let's just plug them in. B squared is 81 minus 4 times 8 times 1. Then we can simplify this to 81 minus 32, which equals 49. And 49 is greater than 0. So to determine how many and what kind of solutions, we will say, since we have the discriminant is greater than 0, we will have 2 real solutions. Okay. Let's have you try this one on your own. So put me on hold, take a couple minutes to try this one on your own, and meet me back here when you're ready. Okay. Oops. Okay, take a minute to compare your work with mine. I identified my A, B, and C. I did B squared minus 4 times A times C, and I ended up getting negative 116. So I concluded, having that negative sign there, that I would get 2 non-real complex solutions. Okay, now sometimes you'll see problems and you're given the solutions of the quadratic, such as in this case. The solutions are negative 7 and 8, and you're asked to find a quadratic equation. So we're kind of working backwards to what we've been doing before. So, as you can see here, we have 2 methods available. Let's start with one, the first method, together. This one is the principle of zero products. So let's just follow the steps. First, we're going to set x equal to each of the solutions. So we have x equals negative 7, and we also have x equals 8. Then we are told to bring the solution over to the same side as x. So for the first one, I'm just going to add 7 to both sides. So I have x plus 7 equals 0. And I'm going to subtract 8 from both sides and get x minus 8 equals 0. Okay. Next, I'm going to multiply the polynomials together. And I'm still going to have that equal to 0. Okay. And last, all I have to do is I need to just FOIL or double distribute this out. So I'm going to have x times x squared minus 8x plus 7x will give me just minus 1x, or minus x. And last, multiply 7 times negative 8, and I get negative 56 equals 0. So that would be one method I could use. Oh, there's another method here, which some of you may or may not like more. We're going to use the properties of sum and product. So again, we're going to follow these steps. Find the sum of the solutions, and this will be your B. So I'm going to write this as negative 7 plus 8, which we know is 1. So that's our B. And our product, we have negative 7 times 8 equals negative 56. And as it says here, that will be our C. Last but not least, we're going to plug B and C into this equation here. So we have x squared minus 11x, and it's minus because that is what it has here, and plus C, or plus negative 56, so minus 56 equals 0. And that is in fact the same as what we got in the first one. So those are two methods. Okay, so find a quadratic equation whose solutions are -4 and 5/3. So I'm going to ask you guys to choose one of the two methods and solve for this one. So put me on pause and take a few minutes to yourself. Okay, take some time to compare your work with mine. Here's the first method. This is the product and sum method. So I first found my B by adding, then I found my C by multiplying. I plugged those in, and I got to this step, and I didn't really like those fractions, so what I did is I multiplied both sides by 3 and ended up getting 3x squared plus 7x minus 20. The second method, I took them separately and ended up multiplying them and set that equal to 0. I double distributed or FOILed it out, and I got the same answer. Okay, check to see, maybe I made some mistakes, maybe you made some mistakes. Just check it out, see what you got. Okay, one more. This probably will be the most challenging one you're going to see. Find the quadratic equation whose solutions are 3 plus the square root of 2 and 3 minus the square root of 2. So we're going to do this one together. And we're going to use the first method we learned. We're going to set these equal to x. Okay. And remember, our next step is we are going to bring this over to the same side as x. So I'm going to have x minus 3 plus the square root of 2 equals 0. And x minus 3 minus the square root of 2 equals 0. Now note, it is very important that you remember these parentheses because I have to distribute this -1 here. There's really a -1 to both terms. So I'll have x minus 3 minus the square root of 2 equals 0. And the same thing will happen with this equation. Our next step here is to multiply these together. So I'm going to have x minus 3 minus square root of 2 times x minus 3 plus square root of 2 equals 0. Now here's a part that we are going to use that'll be very important for us. So we have x minus 3 and x minus 3 in both of these. And we have a square root of 2. So I'm just going to show you guys using my blue pen. So our x minus 3 could be like our a, and our square root of 2 could be like our b. So notice if we had a minus b times a plus b, we know that the middle terms would cancel out, and all we would have to do is a squared minus b squared equals 0. Right? We've learned that before. So we're going to have the same kind of idea right here. So we're going to go x minus 3 squared, so that's our a, minus our b squared, which is the square root of 2 squared, which is just 2. And that's equal to 0. Okay. So next step, we are just going to multiply this out, x minus 3 squared, and if you need me to draw it out, I will. So we would double distribute or FOIL, and we would get x squared minus 3x minus 3x, so minus 6x plus 9. So I'm going to write that in here. And don't forget my minus 2. And to complete this, we are just going to add like terms. And we have our final quadratic. All right, great job today. We'll see you in class. Bring your questions and keep up the hard work.